Numerical number 11 of the problem set in connection with the chapter dimensional analysis. Given energy of a body which is E equal to A minus x squared divided by Bt, and we have to find the dimension of A and dimension of B. So here what we can write, as x square is subtracted from A, we can say that A and x square will have the same dimensions. Therefore, we can say that A minus x square, dimension of A minus x square will be equal to dimension of A, either will be equal to dimension of A or equal to dimension of x square. So, therefore, dimension of A is equal to dimension of x square. X is the distance according to the question. X is distance means x square will have the dimension L square. So finally we get the dimension of A. That is one of the answer. Dimension of A. Here we cannot write this power outside third bracket. Important point we have to memorize. Now, what is the dimension of energy according to this question? Dimension of energy is equal to dimension of A minus x squared divided by dimension of B into T is equal to dimension of x square only, because since we can say dimension of A minus x square is equal to dimension of x square from this relation, and here we can write dimension of B into dimension of T. Left hand side we can write dimension of energy, or comma dimension of B is equal to dimension of x square divided by dimension of energy into dimension of time. So now dimension of x square is L square and dimension of energy is what? M L square T to the power minus 2, and here only time means T. So L square will cancel out, so finally we get 1 divided by M. L square will cancel out, T to the power minus 1. T to the power minus 1. If we check, then L square and L square will cancel out, and this T to the power minus 2 and T will become T to the power minus 1. Therefore, what we can say, dimension of B is equal to M minus 1 T plus 1. M minus 1 T plus 1. So here E equal to x square divided by this one, so B will move to this position, and this is one of the answers. This is another answer. Now we can move to the next problem, which is numerical number 13. Here van der Waals gas equation is given P plus A by B square into V minus B equal to RT. Here P is the pressure, V is the volume, and T is the absolute temperature, and R is universal gas constant. Here what we have to find according to the problem set, numerical number 13, we have to find the dimension of A and B. Dimension of A and B. We have to find dimension of A, comma, dimension of B. So here we have to find where two quantities are added or subtracted. So here B is subtracted from V. So therefore we can say that V minus B will have the same dimension of V and dimension of B. Dimension of V minus B is equal to dimension of V and dimension of B. Therefore, dimension of B is equal to dimension of V. V means volume, which is L cube. So we get one of the answer, that is dimension of B. So we can mark this because this is one of the answer. Next part we have to find the dimension of A. So as A by V square is added with P, means pressure, what we can say, they will have the same dimension. Dimension of P plus A by V square will have the same dimension of pressure, will have the same dimension of A by V square. A by V square. Therefore, we can say that dimension of A by V square is equal to dimension of pressure. So, therefore, dimension of A is equal to dimension of pressure into dimension of square of volume. Here again we can say that we cannot write this power outside the third bracket or dimension sign. Dimension of pressure is what? In L minus 1 T minus 2, force by area, and volume is L cube square. So this power 2 cannot be written outside the third bracket. So we get finally m L minus 1 T minus 2, and here it is L to the power 6. So we get m L to the power 5 T to the power minus 2. That is the dimension of A, which is derived from van der Waals gas equation. We can mark this as one of the answer